Science time with Dr. Fahey. Dr. Fahey. Hey, Dr. Fahey, whatever your name is. What is Noether's theorem?
So Noether's theorem is a thing developed by Emmy Noether, who's probably one of the most famous unsung female mathematicians. But it says that for any conservation rule, there must be, for any symmetry, something that's unchanged in a system, you must have something conserved. So this applies really deeply in physics, especially modern particle physics, but the idea is something like if the whole world has the same laws of physics everywhere, so here or here, and I move, and I do the same experiment here or I do it another place, the rules are the same. So that means there must be something that's conserved because the laws don't change where I am. And so this is the example of translation invariance. So if the rules are the same here as they are here, that's a symmetry, and that means that something's got to not change, and that means that there's conservation of momentum. Because the laws of physics don't change over time, they are the same now as they are tomorrow, as they are the next day, that means that something must be conserved, and the thing that doesn't change conservation in time is energy. So in modern times, we actually think of conservation of energy as being a consequence of the fact that the laws of physics don't change with time, and that conservation of momentum is a consequence of the laws of physics don't change with place. And this ends up being really important because inside things like crystals, you only have certain symmetries, so you can only rotate by maybe 45 degrees or 90 degrees and get things that stay the same. So there always has to be some quantity that you can look at that will be conserved because the system itself has this symmetry. So in modern particle physics, deep down, like how does the fields like the Higgs field and the electric field and all these things work, we now think about in terms of, well, what symmetries does the universe have? Therefore, we must find something that's always the same.
And how's your coffee?
Well, my coffee is both changing in time as the ice melts and changing in volume as I drink it. So I'll have to think of something else for what's conserved about it.
Science time with Dr. Fahey.